वेलकम स्टूडेंट्स। हम डिस्कस कर रहे हैं दी 10th न्यूमेरिकल फ्रॉम द एक्सरसाइज फॉर द चैप्टर मैकेनिकल प्रॉपर्टीज ऑफ सॉलिड्स। सो लेट्स स्टार्ट। नाउ द क्वेश्चन सेज कि वी हैव अ टेलीफोन वायर 125 meter long initially and 1 millimeter in radius. This wire is stretched to a length of 125.25 meters. So you can say when we stretch the wire, the length has increased. This happens when a force of 800 Newton is applied. So stretching is only possible when you apply a force. And what force? Well, a force of 800 Newtons. And using this, what is the value for the Young's modulus for the material of the wire? So एक चीज तो क्लियर है फ्रॉम द इनिशियल रीडिंग कि हमें यंग्स मॉड्यूलस वायर का ढूंढना है यूजिंग अ बंच ऑफ गिवन क्वांटिटीज। तो लेट्स फर्स्ट सिंप्लीफाई करते हैं, सारे क्वांटिटीज लिख लेते हैं। सो फ्रॉम द फर्स्ट स्टेटमेंट हमें पता है हमें लेंथ का वायर का ओरिजिनल लेंथ दिया है, सो लेट्स रिप्रेजेंट इट एज कैपिटल एल एंड दैट लेंथ इज सेड टू बी 125 meters SI units. So we are clear here. Second quantities जो दिया है that is the radius for the wire. So let's represent it as small r and this radius is said to be 1 millimeter. And as you can see, a millimeter is not an SI unit and other quantities are in SI unit. So let's convert it into SI unit. So 1 millimeter becomes 10 raised to minus 3 meters. A very, very simple unitary conversion. Hope you're comfortable with it. Or else you'll have to learn. एंड देन थर्ड क्वांटिटी हमें दिया है दैट इज आफ्टर स्ट्रेचिंग जो नया लेंथ है वो दिया है. सो लेट मी रिप्रेजेंट दैट न्यू लेंथ एज एल डैश and after stretching this new length is said to be 125.25. So as we can see, there is some increase in the length. So previous length was 125 and the new length is 125.25. So some change in length has happened as per the question. And this stretching is because of a force which was applied, and this force ka magnitude is given to us as 800 newtons. So we represent force using the capital F, and this force is of value 800 newtons. इसके बाद क्वेश्चन में हमें डायरेक्टली बताया है the quantity that we are required to calculate. So we are required to calculate the Young's modulus for the material of the wire. So Young's modulus, which we represent it using the symbol capital Y. So ये material की एक property होती है. So that's what we are calculating, Young's modulus. Now let's try to understand what sort of formulas we can use to calculate Young's modulus. So by definition, Young's modulus is defined as force into the initial length divided by the cross-sectional area into the change in length or the elongation, that is delta L. If you observe the formula, F ka value is given to us, so we are sorted on the force department. Original length is given to us, so हम length के original length के मामले में भी sorted है, but area के बारे में कोई information available नहीं है directly at least, और change in length के बारे में भी कोई direct information available नहीं है, but that's why we are the students of physics. हम जो है relation निकाल सकते हैं. So I can say that area for the wire, so telephone wire का shape is of a cylinder, and उसका जो cross sectional area है that is the area for a circle. So we know the formula to calculate the area for a circle if the radius is given to us, and radius is given to us. So in that case, my cross sectional area will be pi r square, that is the area for a circle. Now the second quantity, that is the delta L, well, by definition, change in length is simply the final length, that is L dash, minus the original length. So I can calculate delta L in the formula as well as L dash minus L, that is final length minus the original length. अब अगर हम फॉर्मूला को देखेंगे तो every quantity जो भी फॉर्मूला में participate कर रहे हैं, that is pre-given to us. So a simple substitution of all these values into our formula will fetch us the value for Young's modulus. So let's start. So calculation में सबसे पहले we'll write the statement from formula 1, that is the formula to calculate the Young's modulus for the wire. So by formula 1, y is equal to the value of the force. So in this case, the value of the force is 800 newtons. So 800 into the length of the cable, that is 125 meters. This is the original length. The whole thing divided by the cross-sectional area, so pi r square. The value of pi is 3.142. I hope you know this. R square. So value of r का square. So r का value as per the given was 10 raised to minus 3. So 10 raised to minus 3 the whole square gives us the r square term into the bracket. So let me write this bracket using a different color so that थोड़ा simplify हो. L dash का value as per the given is 125.25 meters. So we write it as 125.25 minus L, that is the original length, which is 125 only. So we close the bracket and we also extend this line. So simple hai, let's do the initial calculations. So we have 800 into 125, let's keep it as it is because I think हमें जो है आगे cancellation का chance मिलेगा. And then 3.4142 we keep it as it is for time being. 10 raised to minus 3 ka square, we can open this bracket, so it becomes 10 raised to minus 6, and let's open this bracket. So 1.25 minus 125 gives us 0.25. So this value is 0.25, and let's simplify it thoda aur aage. So we have 800 into 125 into 3.142 into 0.25 ko let me write it as 25 into 10 raised to minus 2, and 10 raised to minus 2 into 10 raised to minus 6 can be effectively written as 10 raised to minus 8. I hope everybody is comfortable with this. Now we can do some cancellations. So 25 ones are and 25 fives are 125, and we can also multiply 800 into 5, so that gives us 4000. So let's simplify this term. So we get 4000 in the numerator, that is 800 into 5. 3.142 हमने उसको अब तक छेड़ा नहीं है, into 10 raised to minus 8. Which this term can also be simplified further. जो denominator में 10 raised to minus 8 है, let's take it in the numerator. So 10 raised to minus 8 in the denominator, as it goes to numerator, it becomes 10 raised to positive 8. So 4000 into 10 raised to 8 divided by the value of pi, that is 3.142. And इसको हम simplify करेंगे 4 into 10 raised to 11, because 4000 is 4 into 10 raised to 3. 10 raised to 3 into 10 raised to 8 is 10 raised to 11 divided by 3142. And the reason we did so many simplification because from this आपको जो है 4 into 3.142 into 10 raised to 11. So आपका जो ये part है, so this particular part, you'll have to use logs for calculating this value. So use logs for calculations. But for the video, we'll simply skip this step to save some time. So अगर आप 4 को 3.142 से divide करोगे, so you get the answer as 1.274, and 10 raised to 11 as it is, we bring it down. And this is the value for the Young's modulus for our wire, that is, and the units for Young's modulus is Newton per meter square. So the Young's modulus, the value of Young's modulus for our given telephone wire is 1.274 into 10 raised to 11 Newton meter square. So that is your final statement. If you want the PDF of this solution, make sure you check the description. Have a nice day.